Hey everybody, Trey here. Welcome back to another video. Back with yet another forecast discussion for today, as we have seen the SPC upgrade these severe weather probabilities to a level 4 out of 5 moderate risk, as you see in the red shaded region here for today. That is going to include places like Cincinnati, Louisville, Kentucky, Evansville, Paducah, Bowling Green, down toward Nashville, Tennessee, and over into parts of far northeast Arkansas, southern Illinois, and southeast Missouri. St. Louis is in the moderate, places like Cape Girardeau as well. Large enhanced risks around that as well. That could feature some significant severe weather outside of the moderate risk area, and then a slight risk extends all the way over toward the Atlantic coast and down into parts of northeast Texas, including Dallas, Fort Worth, and the Waco, Texas area. So a very widespread severe weather event is on tap for today, potentially a regional severe weather outbreak, particularly in the orange and red shaded regions for today. All severe hazards are on the table, many of which could be significant, starting with the tornado risk, which is at a 15% hatched risk, meaning the threat for tornadoes is elevated, and some of those could be strong, and the SPC even hints at the potential for a long track, higher end tornado within that corridor today. So the 15% hatched risk for tornadoes extends really centered on the Ohio River Valley, Louisville, Evansville, Paducah, Bowling Green, in that greatest risk for severe weather, for tornadic supercells, potentially intense tornadic supercells. 10% hatched region extends outside of that, which could also feature some strong tornadoes, including places like Jackson, Tennessee, and Nashville, as well as Cincinnati. So that is the tornado risk for today, certainly a higher end tornado threat across that area. Another threat going to be significant damaging winds. We could see significant damaging wind gusts in excess of 80 miles per hour today, particularly during the evening after storms congeal into more of a line or multiple line segments, could pose a risk for really intense damaging straight line wind gusts, particularly in the pink shaded region there at 45% hatched area for significant damaging winds. There coinciding with the moderate risk. We have a 30% hatched risk extending outside of that as well. Large to very large hail also going to be a threat for today, potentially some 2, 3, maybe even 4-inch in diameter hailstones centered in that 30% hatched area across the Ohio River Valley, with a 15% hatched risk extending all the way back into northeast Texas. So widespread severe weather event is on the table for today with all severe hazards possible, including some significant. Given the higher end ceiling of this event today, we're only going to focus on today's risk in this video, but real quick, I wanted to at least keep you up to date with our next severe weather outbreak sequence starting tomorrow, Saturday, going through early next week. We have seen some shifts in the outlooks since yesterday morning's video. So here is the outlook for tomorrow, the day 2 outlook for Saturday, May 17th. SPC has a slight risk from parts of Oklahoma and Arkansas southwestward into central Texas, including places like Tulsa, Norman, Wichita Falls, the entire Dallas-Fort Worth metroplex down toward Waco and Abilene. In that slight risk for tomorrow, all hazards are once again on the table. SPC has a 5% tornado risk there centered on North Texas, including places like Dallas-Fort Worth, and a 2% risk surrounding that. Damaging winds and large to very large hail could see another day of 2 to 3 plus inch in diameter hailstones with any supercells there. Storm mode is expected to become more linear fairly quickly with tomorrow's setup, but initial supercells could pose that all hazards risk with the threat for tornadoes and very large hail. There is a conditional target I'm watching up here in that is not really outlined by the SPC yet, somewhere in southwest Kansas into northwest Oklahoma. We do have a marginal risk that extends all the way up toward just east of the Woodward, Oklahoma area, but some of the models are hinting at the potential for isolated supercells up in that corridor, so we'll have to see if the SPC extends the risk back that way. Those could produce all severe hazards as well. Very conditional at this point. We'll see if they alter the risk here coming up, but for now the main risk looks to be tomorrow in the slight risk area there. Then we go into the sort of peak of this upcoming outbreak sequence Sunday and Monday. This is the SPC outlook for Sunday, May 18th, now with an enhanced risk, level 3 out of 5 there, centered on Kansas, with a large slight risk extending up into northeast Colorado, southern Nebraska, down through Oklahoma and northwest Texas. I'm going to be honest here, Sunday looks like one of the better setups we've seen for this area for significant severe weather in quite some time. We're going to have a very robust, tight dry line in place with a low amplitude shortwave overspreading that dry line during peak heating. That could lead to an outbreak of several discrete supercells posing a risk for all severe hazards, some of which could be significant there, especially within that enhanced risk region. Confidence not quite high enough to extend the enhanced risk down here into Oklahoma yet, but we could see that in upcoming outlook. So that is Sunday. Continuing that enhanced level threat on Monday, with now a 30% risk centered on central into northeast Oklahoma and southeast Kansas, places like Oklahoma City, Norman, Tulsa, up into southeast Kansas in that 30% enhanced risk equivalent region on Monday, May 19th. And we could see a continuation of that significant severe threat from supercells with all severe hazards on the table. And then the threat moves east a little bit on Tuesday, which could see, again, another day of significant severe weather there. So multiple days following today's high-end threat of significant severe weather across the central and southern plains into, again, the mid-south, moving into the early to middle portions of next week. But again, today's threat is going to take precedence for this video, as it is a fairly high ceiling event. So let's go ahead and take a look at what's going on as we speak. Let's take a look at the ongoing radar. This is what we have going on right now. I'm recording this just after 9 a.m. Central Daylight Time. And we do have some strong to severe thunderstorms moving across parts of Arkansas into Tennessee and Kentucky at this point. We've had some low-end severe weather with these storms this morning, and there was a severe thunderstorm watch out for these storms that was supposed to end at 9 a.m. Central Daylight Time. We have seen a little bit of an extension in time, given the robustness of these storms that is continuing across parts of Tennessee, now into mostly Kentucky. But these are going to move off fairly quickly to the east-northeast as we go into the rest of the morning and early afternoon. And you'll notice behind this complex, we have pretty clear, the radar is pretty clear here. And this was one of the questions in yesterday's video I had, was the degree of morning convection and how it would impact the environment going into the afternoon for our main round of storms this afternoon. Well, we've kind of answered that question this morning. We have not seen convective redevelopment behind this early complex. Taking a look at our satellite, very clear skies here. As far as at least storms go, we do have some cloud cover across parts of Arkansas down to the south and southwest there, but overall, no storms redeveloping on the backside of this early complex, which should lead to several hours of atmospheric recovery, allowing us to get a fairly intense environment in place for significant severe storms later on for the afternoon round. All right, let's take a look at our upper air maps here. This is our 500 millibar map from the SPC mesoanalysis page. And as we talked about yesterday, this is somewhat of a unique 500 millibar progression. So this is our trough, our closed low from yesterday. It has kind of occluded, as we talked about in yesterday's video, and it's just kind of meandering here out across the northern plains into the upper Midwest and Great Lakes region. It is going to kind of come back to life today, however, as we're going to see a consolidation of the jet streaks here to its south. It is going to take on a much more neutral to perhaps slightly negative tilt and sort of come back from the dead, if you will. But as far as our jet streaks go, we see kind of multiple different areas where we have belts of enhanced flow. We have our secondary jet streak from yesterday just kind of sitting there across the Ohio River region. We have our jet streak associated with the trough from yesterday up there in the Midwest. And then we have another area of slightly enhanced flow back here to the west that has developed overnight into this morning that is going to be one of our main factors here in the setup today. It's going to be what we're going to use to calculate our Omega project calculations. Of course, Omega project is the work that's being done by Chris Broyles from the SPC and others to help discriminate between tornado outbreaks and perhaps lower end tornado events. So let's go ahead and do our Omega calculations, our 500 millibar jet translation speed calculation. So once again, as we talked about yesterday and in the April 2nd breakdown video with Chris Broyles, go check that out if you haven't yet. We are going to be looking at how fast the actual jet streak translates across the U.S. in an 18-hour time frame from 6Z, so the night before the outbreak, to 0Z the evening of the outbreak. That 18-hour period is what we're going to be focusing on. Now, this calculation is a little bit more tricky than yesterday's calculation. Yesterday's jet streak was very evident, very obvious, and we could easily track it across the U.S. A little bit different here today. We have, again, multiple different jet streaks to consider. This is the main jet streak with the trough from yesterday, that secondary jet streak as well down here across the Mid-South and Ozarks. And then we have a couple little features that have developed here overnight back into the sort of Texas Panhandle and Oklahoma Panhandle region. We have one here centered in the Oklahoma Panhandle and one belt of enhanced flow down here in the southeast Texas Panhandle and northwest Texas vicinity. These are going to be, one of these is going to be the one we'll track for today's threat here. And which one is a little bit tricky to figure out, but we are able to do it. If we keep our eyes on this northernmost one, you see it kind of ejects quickly off to the northeast, and then by afternoon it's already kind of up in here across northern Illinois. So that's probably not going to be our main jet streak with this scenario today. So it looks like it's going to be this southernmost one. So this is 6Z, the starting point of our event. And you see, if you focus your eyes on that, you see it translates across Oklahoma by 15Z. It's right there in sort of southern Missouri. And then we get a conglomeration of the overall jet streaks. And it's going to be somewhere in here probably by the afternoon. And you see by 0Z, slightly enhanced flow right in there. That's probably going to be where our endpoint is going to be located. So we're going to use that southernmost lobe as our jet streak in question for the Omega calculation. So here is our starting point right there in the southeast Texas Panhandle, northwest Texas vicinity, somewhere near the Turkey, Texas area, it looks like. We go through in time here to 0Z, and we're going to use perhaps this orange contour here, the southernmost orange contour, looks to be where that jet streak ends up at 0Z, somewhere in southern Illinois. So let's go ahead and calculate that. We'll take a look at radar scope here, use the distance tool. So starts there in the southeast Texas Panhandle, northwest Texas vicinity, and goes up into southern Illinois. We'll use a nice round number here. We'll say about 690 miles for our distance traveled in that 18-hour period. So 690 divided by 18 hours gives us a translation speed of 38 miles per hour. 38 miles per hour to knots is going to be a jet translation speed of 33 knots. That, once again, like yesterday, is lower than the threshold we like to use, the Omega Project uses for the jet translation speed. Usually for higher-end tornado outbreaks, we want to see a jet translation speed of at least 40 knots. And so we're much lower than that 40-knot threshold today, so that could be a factor that might preclude a more widespread tornado outbreak, a little bit of a slower jet translation speed. One thing also to note is the actual speed of the winds and how they increase over the outbreak area during the afternoon and early evening of the event. So this is one of the potential bugaboos that we saw in the April 28th moderate risk outbreak across Minnesota and Iowa. We did not see the winds in the jet streak really increase at all during the day there, and that may have been a factor that the Omega team is now considering as a potential failure mode for these setups. Even with a fast-moving trough, the wind speeds in the trough, generally you like to have those increase above about 15 knots. The actual winds within the jet streak in question, we want to see those increase by about 15 knots over the outbreak area from 18Z, so 1 p.m. the day of the event, to 0Z, 7 p.m. the day of the event. So let's go ahead and take a look at that as well. So here, just going to roughly plot in our moderate risk for today on this plot. So it's going to be somewhere in here. We'll just use that as our expected outbreak area, that the general area of the moderate risk. So keep your eyes focused on that area and the winds within that jet streak. So the greens are going to be the darker greens, 65 knot winds, the yellows, 70 knot winds, and the oranges are going to be 90 knot winds as well. So or 80 knot winds, excuse me. So here is your scale there. I'll actually redraw the moderate risk for you so we can keep that scale in view. So it's just roughly somewhere in there. So keep your eyes focused on that area. You'll notice that we don't see a really robust increase in the overall winds within the that moderate risk area through the day. We go from about 65 knots or so, the darker green contours there, to about 70 to 75 knots or so. So that is going to be a little bit less than our 15 knot threshold there within the outbreak area. We don't see much at all in the way of really intense wind speed increases in that area today. So that could be another thing that might preclude a more widespread outbreak. We don't see those increases really within the outbreak area, more so off to the north. And the winds within the jet streak stay somewhat consistent through the day in the moderate risk area. So As a result, once again, not seeing a super widespread high-end tornado outbreak with today's setup because of our omega calculations here. But we do have some compensating factors today that could give us several supercells with a tornado risk, perhaps a strong, perhaps long track tornado risk. Perhaps the long track tornado risk may be a more isolated threat, and we have the other tornadoes perhaps being on the kind of lower end side compared to what that could be. But overall, not expecting a super widespread tornado outbreak for today, but we could still see some strong tornadoes within this corridor. Let's take a look at some of the reasons why. So first of all, let's go back to our 500 millibar map. Again, that is going to, the jet stream going to consolidate today, provide ample forcing for ascent across this region to allow for storms to initiate during the afternoon hours. Down at the surface, we have a very tight surface flow up there, centering just, again, meandering in western Minnesota into the Dakotas. Very strong surface flow, about 984 millibars, so really deep surface flow there. It has occluded, as we talked about yesterday. It's been cut off from the warm air. Perhaps, though, as we see the trough aloft start to undergo its renaissance, the surface flow may undergo its renaissance as well. We don't really see a robust wind shift out here across any of our outbreak area today, so the frontal zone's a little bit more ill-defined at the moment, but during the afternoon, as we get a little bit more of that warm advection to take place, we could see where the actual frontal zones are going to set up. We do see a bit of a pressure tongue in here. This could be the start of a cold front, maybe a dry line type scenario here out to the west. Could be our initiating boundary as it moves off to the east a little bit today into the Ozarks region. Let's go ahead and take a look, though, at our surface observations here today. So I'm going to refresh this real quick. So these are our current surface observations, and you see mostly uniform winds across the overall warm sector, across much of the Midwest into the Mid-South. Mostly southerly to southwesterly winds out across the warm sector, not a very well-defined wind shift per se, but we do see a moisture gradient. Dew points in the mid to upper 60s and 70s up into, it looks like, southern Illinois, southern Indiana, and Ohio, with more 40s and 50s dew points off to the north. So there does appear to be a bit of a moisture gradient here, even though we don't see much of a wind shift. So that moisture gradient, just going to eyeball it here, looks to be maybe somewhere in this vicinity here. And then we go drop that off into Arkansas. So that looks to be the northward extent of our most robust moisture. Again, we're going to see strong warm advection this afternoon. This surface low may come back from the dead, if you will, across the northern plains into the Midwest, and that will allow the winds perhaps in the warm sector to strengthen a little bit. About 5 to 10 knots now. We probably will see those strengthen just a little bit. And then our dry line back here to the west. Let's go back to our western sector. We'll go to the Little Rock sector here. And this looks to be perhaps the start of another cold front slash moisture boundary here. So you see the winds out of the west generally with more southwesterly winds here to the east. Looks like we might have a cold frontal zone somewhere in that vicinity there. Just eyeballing it here real quick. Looks to be like it might be in that area. So that could be our cold frontal zone slash dry line, whatever you want to call it. We do see a stark moisture gradient across. It looks to be more of a cold front here, with this wind shift with cooler temperatures on the west side of the boundary. So this looks to be our cold front. Warm front, again, draped somewhere across the southern Missouri area into Arkansas, southern Illinois, and Indiana. So those boundaries going to shift. The warm front going to shift off to the north as we see strong warm advection behind the morning round of storms. And that will be a focus along and south of that boundary for storms, as well as the front should shift off to the east just a little bit today into the Ozarks, and into northeast Texas, providing an impetus for storm development there all the way down into northeast Texas, up into Arkansas, and will provide the western extent of our severe threat for today. But a very broad warm sector, as you see, dew points in the 70s stretching all the way from Oklahoma and Texas all the way eastward in through the mid-south and southeast. So a very broad warm sector, lots of real estate for storms to work with today along and south of that warm front and east of the cold front. All right, how about some soundings from this morning? This is the 12Z Little Rock sounding. And as we talked about yesterday, robust instability in play, very strong instability, 2,900 joules per kilogram mixed layer CAPE at 7 a.m. That's pretty intense instability for that early in the morning. Very fat CAPE there as well. One thing to note is that the the convective inhibition, the capping inversion, is fairly weak with today's event. Just a little baby warm nose there below 850 millibars. Very limited convective inhibition today. And that is one of the questions I have. What will that lead to in terms of the storm coverage into the afternoon? Weak capping, usually, this is not going to take much to erode at all. So could be a somewhat early initiation of storms back there across Arkansas into Missouri. But what will that do for storm coverage? With a weak cap, that could mean a lot of storms go up in one area, which could lead to some clustering and the potential for a degradation of the storm mode fairly quickly. Now, the overall forcing is not super strong. We're just dealing with kind of a straight jet streak here, not a ton of forcing associated with it. We go forward in time here, just kind of a straight jet streak wells to the south of the trough. So, there's not a ton of forcing overall, but we do have a fairly weak cap today. Here we are at Nashville. Slightly stronger cap, but still fairly weak overall. Elevated mixed layer in place, strong instability near at and above the freezing level here, going to lead to large to very large hail with the storms today, and especially any more isolated supercells. But overall, one question that still lingers here is the degree of convective coverage, given a weak cap in place, but overall, very strong instability that is expected to grow through the afternoon with strong surface heating. Continued warm advection across these areas will lead to a strongly unstable environment to support explosive convective development by this afternoon. Kinematically, we are already seeing very strong deep layer wind shear in excess of 65 knots there. Some low-level shear at this point. I do suspect we might see a little bit weaker low-level shear to begin with across these areas, perhaps by early to mid-afternoon. The low-level photographs might not be super curved, might favor a large to very large hail threat early on in the setup, and then going into the early evening hours, we might see a ramp up in the tornado risk, especially with any more discrete supercell. That's going to depend on whether or not we see the overall storm mode maintain a fairly semi-discrete nature. But if we do, the low-level shear should ramp up a little bit going into the early evening hours today, and we could see that tornado risk ramp up, perhaps even a significant tornado risk. We should also see, given strong instability aloft, it should be able to transport that momentum down, the strong winds aloft down to the surface for very strong downdraft winds, especially as the storms congeal into a line. We should see perhaps some bowing segments with strong winds in excess of 80 miles per hour, perhaps. All right, how about some model data here for today? This is the 12Z NAM that's coming in as we speak. So here we'll start at 500 millibars as always, and you see our little lobes of stronger flow aloft back here across the southern plains. It's going to shift off to the northeast today and conglomerate into one main jet streak here, really, that is of interest for our event. This one here across Missouri, centered over Missouri into Illinois. We're going to be just ahead of that. Mostly just broad west-southwesterly flow here across the region. A little bit of curvature out back with this jet streak, as you see there, going to shift off to the east, and that should provide just enough impetus. And again, that's why the forcing is a little bit on the weaker side. We're just dealing with this low amplitude feature down here and this more straight jet streak. So that could lead to a more discrete storm mode today, but again, weak capping could preclude a purely discrete storm mode. But overall, we have enough forcing for ascent for storms, should be able to get that going by perhaps even early afternoon across parts of Arkansas and Missouri along the cold front, shifting east with time, and also south into northeast Texas as the atmosphere becomes more and more favorable through the afternoon. We should see the storm coverage increase going into early evening, and then we'll see things congeal into more of a linear clustered mode going into the evening hours tonight. But overall, should have plenty of forcing here for severe weather with this jet streak moving through the mid-south. Here is our surface pattern for today. So our surface low has been cut off from the warm, moist air at the surface, meandering up there across the Minnesota corridor, going to start shifting off to the east. Once that the trough aloft starts to take on a better geometry, we'll see the frontal zone also start to shift off to the east. The cold front will kind of see reconnect here with the surface low a little bit. Cold front down in there, shifting to the east across Texas, Oklahoma, Arkansas, Missouri. And that will be perhaps a focusing mechanism for storms later on today. And that should shift off to the east going into tomorrow as well. And then we'll be left with some remnant moisture south of the remnant front, which could turn into a warm front tomorrow for the severe weather event Saturday across the southern plains. All right, moisture. Let's go ahead and zoom in here to our sector of interest. So here is that moisture. So you see today broad 70s dew points in the purple here to the south, Texas northeast and northeastward. And this is our basic moisture gradient here. You have kind of maybe two moisture gradients out in here, between our 50s and 60s, and then our 60s and 70s down there. But overall, broad warm sector to work with. That shifts off to the north with time. We see we see the dew points getting eaten out there, which indicates convection here by early afternoon. Yesterday's NAM run was showing lots of early convection persisting, which lent some doubt into the forecast as far as the degree of early convection. Those have been answered as the ongoing complex now will shift off to the east fairly quickly, leaving plenty of time for the atmosphere to recover behind it. But here are going to be our boundaries. Your warm front here at 18Z going to be somewhere in here, and the cold front going to be somewhere in there as well. So let's take a look at our initiating mechanism here. It looks like it will be the cold front. Could be strong warm advection here within the warm sector as well, and then the warm frontal zone off in the southern portions of the Midwest. Let's just quickly take a look at storm mode here. So we see our shear vectors are somewhat perpendicular to the initiating boundary, the cold front back in there, despite the tendency for a more northeast to southwest oriented front. Shear vectors are nice and perpendicular to that, so that could foster a more discrete mode. We have somewhat more subtle forcing, along with the favorable shear vector orientation, could lead to a discrete to semi-discrete mode for several hours here today out across these areas. Now, along the warm frontal zone, that could be a little bit different. You see that those shear vectors are very much parallel to the warm front, which could lead to a lot of storms near the warm frontal zone and could lead to a slightly more messy mode. Now, in the open warm sector as well, we could see more pockmarked random convection here, which could favor discrete supercell. So overall, there's just going to be multiple rounds of severe storms today. We have this early round moving out. We could see development along to the south of it, perhaps the remnant outflow boundary there, which could lead to some supercell activity there. Any warm sector convection out in here, Missouri into Arkansas, Tennessee, Kentucky, and we could see storms back along the cold frontal zone back farther to the west. Things shift off to the east pretty quickly going into the evening hours today, and we should have plenty of juice for robust severe storms along this corridor going into the afternoon. All right, let's take a few soundings here. 21Z, I'll try to pick an uncontaminated sounding there from southern Illinois. We'll take one down here, maybe across northeast Arkansas, and then one down to the south closer to the Arklatex near the cold front. So here's what we have going on by 21Z on the NAM. This, once again, is going to be in that southern Illinois region, right within the moderate risk there. So, again, pretty confident that storms are going to fire in multiple rounds there by the afternoon in this kind of an environment. Very strong instability, 4,700 joules per kilogram mixed layer CAPE here on the NAM. Even if that is an overestimate, you take a little bit off of that, we still have a strongly unstable environment. It's very steep lapse rates aloft, elevated mixed layer in place. Not a ton of capping associated with that EML that might lead to widespread convective initiation in a few hours' time. But overall, very strong elevated mixed layer here. Strong, here's the freezing level right there. Strong instability at and above the freezing level should provide for that large to very large hail threat with storms with supercells today. Strong low-level instability as well, just like we saw yesterday, could lead to a little bit of help in overcoming, at least initially, somewhat more modest low-level shear. We do see a little curvature here by 21Z in the hodographs, strong deep layer shear for supercells, but somewhat limited low-level shear, adequate for tornadoes. You do see a little bit of veering in the low-level winds here with time, interestingly enough. So that'll be something to watch. The NAM usually tends to be a little bit more aggressive with surface backing, winds, meaning winds out of the south or southeast. Here, fairly unidirectional profiles out in here. We do have enough curvature to perhaps support a tornado risk, but this is why I think we're going to see more of a large hail and damaging wind threat initially. Maybe a tornado risk, not necessarily a significant tornado risk in the initial stages of convective development today, given somewhat weaker low-level shear, somewhat more unidirectional profiles in the lower levels of the atmosphere. But overall, strong instability, strong low-level instability. Any boundaries left over from the early convection, any of our synoptic boundaries will be able to have a lot of vorticity along them. Any storms near them may be able to efficiently tilt and stretch vorticity into the vertical thanks to strong low-level instability to support a tornado risk. And given that we have strong instability in place, sometimes the rules just go out the window. Northeast Arkansas here, much of the same. Strong instability, strong EML aloft, large, very large hail. Once again, initially, fairly limited low-level shear, adequate for maybe a low-end tornado risk early on, but mostly a large hail and damaging wind threat with those storms. And then down into Texas, fairly limited low-level shear there as well with strong instability. Should favor mostly a large hail and damaging wind risk along the cold front back into the Arklatex region, perhaps in toward DFW. Then we go toward 0Z. We should see a little bit of an increase in the low-level wind fields. Let me try to take some uncontaminated soundings from out in here, and then we'll take a look at those. We'll take a look at those same areas. So kind of western Kentucky, northeast Arkansas, down into the Arklatex region. So here you go. Here by 0Z, we see a much different profile. Instability still very strong, upwards of 4,000 joules per kilogram mixed layer CAPE. So plenty of instability to go around with today's setup. But we do see a change in the wind profiles here. A little bit more backed low-level flow leading to stronger low-level shear, more strongly curved hodographs, upwards of 330 meters square per second squared effective storm relative helicity, strongly clockwise curved hodographs, would favor a transition to perhaps a tornado risk, perhaps significant tornado risk given strong instability and this much low-level shear by late afternoon to early evening. Now, again, it is going to depend on storm mode. If we see storms congeal into a line a bit faster, then that may mean more of an embedded QLCS tornado risk and more of that significant damaging wind risk taking over. But any discrete supercells left in this environment would have the potential to produce significant, perhaps long track tornadoes in this kind of parameter space. Strong instability, strong low level and deep layer shear, certainly favorable for significant tornadic activity. Down to the southwest in northeast Arkansas, we still see somewhat more muted low-level shear amid strong instability, so perhaps not as much of a strong tornado risk down the farther southwest you go, but still would be adequate for maybe a tornado or two down there, given a little bit of curvature in the low levels of the hodograph, a little bit of low-level shear there, nearly 200 meters squared per second squared effective storm relative helicity. Down toward the Arklatex region, mainly maintaining that large hail and damaging wind risk with strong instability and very limited low-level shear there. So definitely looks like the sweet spot for significant tornadic activity is going to be where that moderate risk area is positioned, southeast Missouri, northeast Arkansas, northeastward, mostly perhaps maximizing there in that southern Illinois, southern Indiana, Kentucky corridor, right in that hatched area I've just drawn. So that's where low-level shear tends to be strongest, it looks like, at least as the NAM has depicted it here. But again, it's going to depend on storm mode. And let's take a look at some cams here to see how the models are handling our storm mode for today. So here is the 12Z HRRR. Let's go ahead and go forward with time. Here's our early convection associated with the severe thunderstorm watch this morning. That will continue to move off. We do see the HRRR has some convection back in here out across northwest Arkansas. We don't really see that at this point. Clear skies back in here. So this HRRR run definitely over convecting out in that region, but those look like pretty minimal. They'll have pretty minimal impact to the environment. Then by about 20 to 21Z, we see convective initiation all the way up from Illinois southwestward along the cold front. We do see a fairly cellular mode here, some semi-discrete to discrete supercells along that corridor, which would foster that all hazards risk. Perhaps initially more of a large hail and damaging wind risk, transitioning to more of a tornado risk there. Centered looks like to be centered on that southeast Missouri corridor down into southern Illinois and Indiana, western Kentucky. The HRRR is depicting very discrete to semi-discrete supercells there with a risk for all hazards. This is at 6 p.m. this evening. As that low-level shear is ramping up, let's take a quick sounding just to the south of those storms to see what the HRRR environment shows. A little bit contaminated there. Let me take a sounding a little bit out ahead of that to get a better, less contaminated sounding. And here is your environment at 6 p.m. Certainly strong instability, 4,500 joules per kilogram, or excuse me, 3,900 joules per kilogram mixed layer CAPE, with enough turning there in the low levels to support a tornado risk, and with strong instability in play, perhaps a significant tornado risk. Those storms stay pretty discrete for a while and then eventually kind of congeal into multiple bowing segments there. Strong, damaging straight line winds within these bowing segments and these line segments, very likely as they move off to the east into Kentucky, Tennessee, and the southeast tonight. So her certainly favoring a pretty robust scenario with multiple discrete supercells all the way up into Illinois as well. Could foster a tornado risk for any supercells that are anchored to the warm front up there in southern Illinois and Indiana. And then in the warm sector down here east of the cold front, more discrete activity as well, with more linear activity down into Texas, where the low-level shear is weaker. All right, WRF ARW model here. Let's take a look at that. So has the morning convection. It too, interestingly, also has this early convection there in northwest Arkansas, which of course, as we know, is not happening. And interestingly, it blossoms that into more of an MCS through the day that really wrecks the environment. So this is a model run that we can kind of throw out here. This is just not happening at this point. We'll see if storms tend to fire back there. I don't think that's going to be likely. We don't really see any development back here. Maybe some high-level cumulus out in this area. So the model's certainly picking up on some stuff that is not actually happening, and this ARW run certainly looks to be one that we can throw out. And so let's just toss that one. We'll go to the NSSL WRF model. Here we go on, and interestingly enough, the NSSL WRF also has storms there. It shows you why observed data is so critical. We're not seeing any storms in that area right now. Could we see some back out in there given the arrival of forcing early on? Perhaps. And if that does happen, let's just take a look at the contingency here. If we do see eventual storm development here late this morning, that could be an issue for later on. These models do have that stuff blossoming into a convective complex that kind of ruins the environment later on. So we will have to watch that. Multiple models do have this solution. The NSSL WRF, if this does come to fruition, that would kind of ruin the environment in the moderate risk area for later on, would lead to less chance for recovery and just more of an overall messy type mode with a significantly lower chance for significant tornadoes. But not seeing much in the way of potential storm development out in there at this point. Let's take a look at the most up-to-date HRRR run here to see. This is going to be the 13Z, so this will have a better handle on the current convection. It has, interestingly, it has blips out there in northeast Oklahoma that become storms. So this is really interesting. So this does have initial development out here across northeast Oklahoma, southwest Missouri, northwest Arkansas. And that becomes one of the main rounds later on. These become supercells here along the warm front, trailing supercells there in the warm convection regime across Kentucky, and then we see the cold front light up later on. So very complex solution here. Right now, not seeing much in the way of storm development here out across this area. But we will have to watch that, as that could either become a complex that kind of ruins the environment in the moderate risk area, or it could become the main show. Again, with the forcing arriving fairly early in this event, I think we could see storm development by midday to early afternoon across Missouri and Arkansas that either could become a complex that wrecks the moderate risk area or becomes the main show later on. Just something that we're going to have to watch here as we go forward with time. But overall, right now, leaning with the solution that would suggest that we are going to see significant tornadic supercells out across this corridor later on into the afternoon hours today. But so the CAM's a little bit all over the place this morning, and that's why observed data is so important in these forecasts. So that is going to do it for this video. This is our outlook for today, moderate risk level 4 out of 5 out there across really centered on the Ohio River Valley. As that warm front and the warm sector translates northward with time, we're going to see a broad warm sector with multiple rounds of severe storms today within the red shaded region there in particular. So again, St. Louis, Cape Girardeau, over toward Nashville, Paducah, Bowling Green, Evansville, Louisville, Cincinnati, all in that moderate risk level 4 out of 5 for today. Large enhanced risk surrounds that, which could feature significant severe weather as well. Once again, all severe hazards are on the table. Going to depend on storm mode, any early convection that does fire out there, and what it will become out across Missouri and Arkansas translating eastward. But assuming we have tornadic supercells, which looks like a decent possibility today, they could foster an intense long-track tornado risk, particularly in the 15% hatched area there, the red shaded region you see there. Also a 10% hatched region extending around that, which could feature strong tornadoes as well. Large to very large hail all the way along the cold front back into northwest Texas, centered on the Ohio River region. Very strong instability at and above the freezing level today could foster very large hailstones with those supercells. And then significant damaging winds, 45% hatched risk there for significant 80+ mile an hour damaging winds, especially tonight as storms congeal into more linear segments. Those could really feature some significant straight line winds. So very potent event on the table for today. And once again, after today, we're going to have a fairly active period as well, with another outbreak sequence beginning tomorrow through the weekend and early next week, with multiple days of perhaps significant severe weather on tap for the central and southern plains into, once again, the Midwest and Mid-South by the early to middle portions of next week. But today, very potent setup that we'll have to get through first. If you live in these areas, especially the orange and red shaded regions there, make sure you have multiple ways of receiving warnings. Have your weather radios handy, and we'll get through this okay. So with that, thanks for watching, and we'll see you in the next video.